Okay, good morning, everyone. I hope you hear me well. And let us start our lecture. It's Wednesday, October 28th. It's our lecture number 26. So, as you remember, your homework is due today, right? So, many of you submitted it. If you did not make it yet, please submit it. Please do it as soon as you can. And then, because I really want to post my solution, so you will have it for your exam. Your exam is on Friday. Exam will go in the same manner as exam one. So I do request you to be on Zoom and have a camera such that I can see what you are doing, right? And exactly the same procedure. Exam will be posted and you can type in it. You can use PDF, you can use Word document, you can print out and write down and scan and send it to me and upload it exactly like exam one. You know the process. Now, I should tell you, and today we have like review session for it, and I should tell you that I'm thankful for you for your pre-evaluation that you did. Again, it's an anonymous. I don't know who say what. Uh, and basically, I really appreciate what you did. So just few, so, and basically, some of your comments are really fruitful and we can follow. Some of them are fruitful, even we cannot follow them. So let me summarize. So what menu you suggested? So first and foremost, many of you really don't like that this course is online. Well, me too. I really want to see you in person, but unfortunately, it's not me who can make this decision. And please don't blame me. Don't evaluate me based on this. It's university decision. We know about pandemic. We know what's going on. It's not our choice. And why I want you to teach you in person, because when I teach you in person, I see your eyes, I see you, and I can interact with you. And if I see that you are sleeping or you don't follow me or you don't understand, by your faces, I see it. And then I can repeat, I can stop, I can do something. Now I don't have this chance. And that's why it's your task to understand what you know, what you don't know, and make sure you have time to ask questions and so on. So that it is. And as usually from year to year, you don't like essays in homeworks. You say that they are useless for your exams. I agree. I told you why you have this essays, because this is for ABET accreditation. Since you don't want your diploma to be a pumpkin at some point, we need to have ABET accreditation. And one of the tasks of this course is to demonstrate that you know application on thermodynamics, you can explain them, you can follow it. That's why we have this essay. If you don't have essays, then we would have seminars and spend lectures on this, which we don't want. And you may pay attention that I asked TA to be quite generous when grading these essays, but we need to have it to report. And remember that in homework 3 and homework 5, you don't have essay, because I don't want you to waste your time. I want you to be better prepared for the exam. Okay, so that it is. Other questions, okay, people say that, okay, they're not happy that homeworks, that everything is based on exams and homeworks are only 10%, 90% come from exams. And they ask for other ways to get grades. Well, I give you this. Don't you remember about optional quizzes? Well, so far we had 4 quizzes. So if you did excellent all the quizzes, you already have extra 6 points. Each was 1.5. So you have extra 6 points towards your final score. It's great if so. And maybe we'll have a couple of more, one or more quizzes if you have time at the end. Again, yeah, you did not get 6 points because they're hard, but I give you this chance. Plus you have bonus tickets, right? Bonus, not tickets this time, bonus points, and I give 0.5 points to many of you after each lecture. So I tell you, many of you will have, not many, but some of you, good fraction of you will have more than 100% as a cumulative score. And then when people ask me, why don't you curve final score? I tell you why. Because if I curve it, you will fall down. Believe me, some of you will have 105, 107 as a cumulative score. So you have this chance. Now, why homework is just 10 points, not no more? It's intentional, because I don't want you to worry too much about homework scores. I know I cannot control much if you copy your homework and if you do it yourself. If homeworks will cost more, it will be stimulus for you to be hectic, to write down it promptly and to get score. I want you to do your homework yourself because exams will be similar. You already see it. Quizzes are similar. So you better do your homework yourself. You better fail on it. You better get F on your homework. But then you will see the solution which we are posting. Compare, recognize your scores, and come and write your test well. Does it make sense? If your homeworks would cost more, it will actually spoil your exam. And believe me, all our bonus points, optional quiz homeworks, it's good, but they don't replace your exams. So if you are in a borderline, they help. They actually can help you to promote your score by one character. From B to A, from C to B, you can get. But if you fail at your exams, now nothing will help you. So exams are most important, and please be prepared. Other suggestions. So that's I know these suggestions. Well, some people say that they cannot attend help session, office hours because they're busy this time. Well, you know, we should have this. We cannot make everyone happy, and we cannot. There will be no time when 100 people are free, unless I will do it at like in the midnight or in the middle of the night. But still, it will be not helpful for you. Plus, we have many people who are abroad in different time zone now, especially in Europe, in Asia. It's really very problematic. So if you cannot make it, we will try to help you. If you really need to ask questions, please, what you can do, email to me, call me, email the TA, Eric. We will try to find time to negotiate and talk to you. Again, if I get 100 messages on Friday morning, maybe I will not address all of them, but you should understand this. But you already see that I try to reply your emails and I try to reply those who wrote to me. I really try to be active and proactive and reply timely. So whatever we can do for you, we try to adjust. Okay, people say that, okay, they want to have marked graded homeworks and exams. You have it, isn't it? Everything is on the campus. So take it. I believe it's there. Marked tests, marked quiz, well, not quizzes if they're electronic, but tests and homeworks are there. Please download and compare. Yeah, we don't post final authorial solution for your tests, and you know why? So you say that you cannot hear me? That's strange. Okay, well. Okay. Wow. At which point you don't hear? Okay, what should I do now? Should I like rebound? Something is, okay, let me try to unmute. I am unmuted. Do you hear me now? Anyone hears me now?
Yeah, you're good now.
Okay, so let me reply, please. So did you hear anything at all, or it stopped at some point?
Up until about 30 seconds ago, I don't think any of us heard anything.
30 seconds. But okay, but when I started, you 5
You
minutes
were
that I
you
was
were on
talking.
your way to the next point that you were talking about. That people were like dissatisfied with, I think. And then after that, we couldn't hear anything.
Okay, so did you hear when I discuss about help sessions, about help session about 90 points for exams that people want like extra credits? Did you hear about this?
Yeah.
Okay, good. Okay, I continue. So again, I'm talking about what your suggestions. So there are some things that I really tried that you're right. So some people, and yeah, I apologize, please, if you don't hear me again, please report this. So some people, they really ask to have lectures to follow a 50-minute rule and stop at 11:50. Well, of course, if I'm in the class, I would really do it. I would, and because there will be another class. I actually considered there is many disadvantages of online class, but there was some advantage that since I post the lectures, I try to use a little bit more time to give you more material because we are lack of time. Everything is posted and you can listen at any time. And also what I used to teach at the end of the lecture, I used to repeat. But it's okay. If it's many people reported this, okay, I will do my best at start at 11:50. I will do it. Maybe it makes sense. I will follow. Well, many people suggested more examples in the class, and so we will do it, and we also do some examples. And please remember that most practical applications start with chapter 5 when we start talking about open systems. So we will do it, but still remember something. Remember that we are limited in time, and we started 1 week later, and we will end a week earlier. Yeah, we don't have Thanksgiving break like is usual. We will have only 2 days. We don't have Columbus Day, but we are limited in time, and our syllabus is still the same. So we cannot really go through all examples. So when I ask you, that's why we have homeworks and you have your textbook. And when I ask you to go through textbooks, through examples in the textbooks, through problems, please do it. And I tell you, I don't replace your textbook. Your textbook is still much better than our lectures. But we will do more examples. Another point, people really wanted example. Well, if I'm in person class, what I typically use? I use slides, I use Blackboard, and Blackboard is typically very big, so everything is that you can see. Simultaneously, you can see screen, slides, and different problems on the Blackboard and derivations and some basic things. Here, it's problematic, and you should, even if you have several screens, you should jump from one to another. I will think how to make it how make it better. So some people prefer that you solve problem from the very beginning rather than I show something in the textbook. That's relevant. Other people suggest to put some examples into the slides. I will do it, but again, no reason to do it much because you still have your textbook. But I will try to go through examples in more details. But again, we cannot go through all examples. We cannot do all of them. So what other questions? Return graded homeworks. Again, graded homeworks are posted and they're marked. And I do recommend you that we post all solutions to the homeworks. We do solution to the homeworks, solution to quizzes. You have it in your hand. And please compare solution with your knowledge and see what you don't know. It's really important. Some people suggest to go through optional quiz in the class. Well, if you have time, we can do it today. We will see. But again, since you already have your solution, we better do something that you don't have. But I will try if you have time for this. So that's that. But I really thank you for your suggestions. And at least let's do 2 things from it. Let's have 50 minutes limit. Let's follow it. And I will try to do something with examples in a different manner. Another point, some people ask me to have more detailed slides. Some people ask to have abbreviated slides. It's hard to balance. Again, we have slides, but please, it does not mean that you must know everything from the slides. There are extra material in the slide, like there is extra material in the textbook. Now, what I want to do now, and again, it's like review session. So today we don't have chance to recall all the topic, right? But what I want to do typically today and what I do at help sessions. And I recall today at 5 o'clock, there will be another help session that I will give. Please come through Zoom link, the same like for TA help sessions. I want you to caution you about some mistakes that you typically do. So that it is. So at this point, let me share my screen with you, right? Let me share a screen and let me show you something. So basically, that is the slides that I wanted to show. So again, you have summary slides, right? You have them, but it's your last option to prepare for your exams. You need to go through solutions to your homeworks, and you need to read your textbook. Only after this. Please don't come to exam just with the summary slides. And so your exam 2 will be based on chapter 4 and 5. But I caution and encourage again. Many of you already forgot chapter 3, or at least you don't remember it very well. If this is your case, please. Please follow it. It's still backbone for the entire course. For instance, in the homework that you just need to deliver today, right? It was a problem, just example, it was a problem number 8. and it was throttling wells. And many people ask me, so they arrive that at the very beginning at the inlet, you have subcooled liquid. So Freon is subcooled liquid. And people say, okay, where can I get subcooled table? So what should you do? Yes, there is no table for subcooled Freon. But remember the strategy that you can approximate the property of subcooled liquid as saturated liquid at given temperature. Remember? And this is the only time when you can violate tables, when you can violate phases. Never approximate vapor as a liquid. Never approximate superheated vapor as a saturated. But that's the only exception. And that's what you can employ. That you expected to do. Well, it's not a crime that you forgot about this and didn't get it, but it means that it's a good time to repeat chapter 3. So if you are still not flexible with it, go through homework number 3, see the solution, make sure you're okay, and then chapter 4 and 5. So here it is. So what you should remember. So what are basics for chapter 4? Again, you know all the subjectives, what we did. So in fact, here we extended your knowledge base from chapter 3 to several states. In chapter 3, you typically dealt with one state. Your task was identify state and find some parameters. Now you have at least 2 states, maybe more. So what you must remember, what's classical mistake? If you identified state 1, you still know nothing about state 2 and other states. You should solve this problem from the very beginning for state 2, state 3, and so on. Please don't confuse. Read the text body and try to identify. So that's what we did in chapter 4. In chapter 4, we employ first law to closed system and solve some problems. So how first law look like? I recall, it simply we say that it's energy conservation. For closed system, mass cannot go in and out. So we say that energy change in a system, it's energy propagating through a boundary. And it can go through what? Through heat and work. Remember, heat is something related to temperature difference, and work is everything which is not heat. This is our definition in thermodynamics. We don't talk about boundary work here. We talk about work in general. It can be steering work. It can be electric heater. It can be mixer, any kind of work. Remember convention sign, Q minus W. If you get passive voice and active voice, classical mistake. Q is positive, W is negative here. If work is done, if heat goes into the system, it's positive. If work is done on the system, it's negative. If work is done by the system, it's positive. If heat is released from the system, it's negative. Please remember. In differential form, it looks like this, right? So that's I request you to remember. Yes, there are some questions I will address. So I want to go briefly through these basics, and then we will talk a little bit more about exam, and I can address some of your questions. So that is first law for a closed system, right? That's how it looks like. We spent, again, I recall here WVU is work, and it can be electrical work, it can be any kind of work, but plus boundary work. And boundary work is one of your major focus here. When you have like a piston cylinder assembly, when this piston goes up and down. So what you remember, again, heat and work, they are not properties, right? Why they're not properties? Because they don't depend on state, they depend on the process. Like I say, every instant I can ask you how much you have in your pocket and you can, on a bank account. And if you want to share, you can say this amount. But I cannot say how much you spent instantaneously. You don't spend instantaneously. It's a function of time. The same story here. Heat in work, it's what change with time. And we are lucky because of this, because there is no conservation of work and there is no conservation of heat. There is only conservation of energy. So heat can be converted into work and work into heat. And that's why we can use it. And that's how our whole manufacturing work, how steam machine works. We manage to convert heat to produce work. So if you have a cycle, work of a cycle is not zero. Why? Because you may see all these pictures. Remember that there are many ways how you can go from state 1 to state 2 in this picture, right? And basically all these trajectories, A, B, and C are different. And in all the cases, work done will be different, right? And what will be work? Remember what is work? In PV diagram, work is surface area under the curve, right? That is work. Now, if it's like this, if you go from left to right, work is positive. True? In contrast, if you go from 2 to 1, if you go backward, work is negative. Like you see in picture above, trajectory A, work is positive, trajectory B, work is negative. If you go over the cycle, what you have here, it will be work over the cycle. And you remember calculus. If you have, what is this integral? It's so this work is what? It's integral PDV, correct? This is over the cycle, integral PDV. And this is just, each work will be integral PDV along the trajectory. So what you remember about this? Integral can be positive and negative. That's most important, right? Surface area is positive, but then the integral is equal to this value, or you take, it will be negative value, right? So integral can be negative, while its absolute value, its module is equal to the surface area. So very simple to remember this, our universe expands. So why it expands? Because there is nobody to compress it outside. So it expands, it's work done by our universe, and it's positive. It's active voice. So if you have expansion, your integral dV is, like you see here, your integral dV is positive. So it means that you have expansion. If you have compression, this work done on the system, it's passive voice. You cannot shrink yourself. You cannot be shorter. Somebody should compress you. So this work will be negative. The absolute value may be the same, but the work will be negative. If you have cycle, remember, when you go clockwise, your work is positive. When you go counterclockwise, it's negative. It's trivial, but it's classical mistakes that you're going to do. And in your exam, it will be questioned like this. And I will ask you, is this work positive or negative? Is this heat transfer positive or negative? If it's delivered to the system or from the system, is this work done by the system or on the system? You should be able to address it. You should be able to answer. Now, so this is one equation that we consider. And basically, we discussed several equations, right? So another equation, how equation of the process look like. And we discussed what we discussed? Polytropic processes. So what is polytropic? It's a process which looks like this, PV to the power n is constant. Why we talk about polytropic processes? For two reasons. One, because it's mathematically nice to deal with this, it's easy to integrate it. If you calculate boundary work, it's easy to integrate this polytropic. True? Second, because most of the simplified processes we deal with, iso process, how we call it, are polytropic. So in this equation, n is what we call polytropic index. It's some constant, it can be arbitrary. It can actually be 0, it can be negative, it can be 100, it can be root square of 2, whatever it is. And you should be able to find it, or it will be given in the text. But in fact, most of the processes we deal with are polytropic. So if n is equal to 0, we have isobaric process. If n tends to infinity, we have isochoric process. Now, if n is equal to 1, generally speaking, it's nothing, but if you have ideal gas, it will be isothermal process. And another point, remember, when we talk about specific heats, that if, again, for ideal gas only, if n is equal to k, Cp over Cv, it will be adiabatic. That's why we deal. So please remember how to deal with polytropic processes. So here's the equation we derived it, how it look like for polytropic process. So if you calculate boundary work, that is the formula where you arrive to. So basically, common problem will be like this, that you know state 1, you know something about state 2, you know polytropic constant n, so you should be able to identify state 2 and find boundary work, calculate this integral. Does it make sense? In your homework 4, there were problems like this. Please go and check. So what you should remember about here? Particular case. You may see this formula that I deal with. You may see this formula. So you see here n, right? So what is, you may realize, if n is 0 here, then pressure will be constant, and you come to equation P delta V like here, right? So what you see in gray scale here is it's not another formula. It just simply goes from this formula when n is equal to 0. Do you agree? If n is equal to 0. If n tends to infinity, then what? Then you divide by infinity, you come to 0. And then understandable for isochoric process, boundary work is 0. And it's true because here, what is isochoric process? It's vertical line, and the vertical line surface is 0. Again, you may have rigid tank with electric heater or with stirring process. Then boundary work is 0, but total work is not 0, please remember. Now, particular case. You have this fraction here, right? But you realize that if n is equal to 1, that's your particular scenario. If n is equal to 1, what is it? Then you will have singularity, 0 by 0. You cannot solve it. So the formula that I consider here works when n is not 1. If n is equal to 1, you have another formula, which gives you logarithm here. Do you understand? And here PV, it can be P1, V1, P2, V2, it does not matter because it's constant in that case. If n is equal to 1, your polytropic equation will be PV is equal to constant. Please pay attention. Here I show you when many of you are going to do mistake in your exam. So if you employ general formula for n is equal to 0, it will work. If you employ this formula for n is equal to infinity, it will work. If you employ this formula for n is equal to 1, it will not work, but you will divide, you will see 1 over 0, you will realize something goes wrong with you. Now, classical mistake that you can use this equation in any case. You employ this equation for n is equal to 1.4. So formally you will calculate it. Formula works, you will get an answer, but it's conceptually wrong because this is wrong formula. We did not derive it. This formula works only if n is equal to 1. Remember how we derive. That's why we derive. So that I request you to remember. That's classical mistake. You may lose 20 points. You may lose your good score if you confuse these formulas, because then you will, everything will be wrong. From here, realize these are different. Does it make sense for you? So that's classical mistakes that you may do. Another point, remember, sometimes we deal with enthalpy. So basically, if you have another point, if you have particular case, remember enthalpy. It's our major parameter in chapter 5, but even here in chapter 4, it comes in. U plus PV, internal energy plus forward. And if you have constant pressure, heat transfer is equal to change in enthalpy. So instead of dealing with V and PV and internal energy, you can deal with enthalpy. Q is equal to delta H. That's a good hint to deal with. Now, if you have a cycle again, remember for a closed system, heat transfer over cycle is equal work transfer over cycle. And that's important to remember. That's how all our devices work. And so you may realize there is no conservation of heat and work, they are coupled. If you have a power cycle, if system consumes heat and generates work, like steam machine, they both are positive. If you have refrigeration cycle, for instance, when you transfer heat and consume work, they both are negative, but they are equal. Remember, we talk about specific heats. What are specific heats, CP and CV? Remember that since heat and work transfer depend on trajectory, depends what process you look like. And remember, in isobaric and isochoric process, these are different. So generally speaking, what is specific heat? What is heat capacity? It's how much energy you need to increase or decrease the temperature of 1 unit of mass, or 1 mole, or 1 kilogram by 1 degree. And remember, CP and CV are different. Remember how we define it. And basically remember that we classically derive why we talk about CP and CVs. Because there is nice expression that CV is given by internal energy derivative, CP is given by enthalpy derivative, right? And why it's nice? Because enthalpy and internal energy, specific values, they are in your tables. They are properties, which makes that CV and CP are also properties. they also depends on state. They are not functions of the process, they stay, so they are tabulated. You can get it from the tables. And we discussed many things, how to deal with it. And remember, for ideal gas, we have classical, very nice MAE relation. So Cp minus Cv is equal to R. Also remember, we talk about bar values. So what are bar values? Bar value is the value per unit mole. There is U bar, H bar, C bar. How we got bar values? If you want to go from normal value to bar value, you just multiply or divide on molar mass. That's classical way, that's what you can do. So please remember MAE relation, and that is for ideal gas only, okay? It's for ideal gas, it's not general case. And also remember what we call K is specific heat ratio, it's adiabatic index, it's Cp over Cv. So these two equations that you have, let's say this one and this, you have set of equations. And definitely you had problem like this, it was problem number 3 in your homework 4, and you will have such a problem in your exam, I guarantee you. So please make sure you know how to solve this. So here you have 2 equations and 4 variables, Cp, Cv, I, and K. If you know 2 of them, you should find 2 others. It will be question like this. You know Cp and R, find Cv and K. You know K and Cv, find Cp and R. Or something like this. Please remember. Right? That is for ideal gas. If you talk about solids and liquids, this is not the case. For solids and liquids, remember, it will be something like this. Cp is about to be Cv. In chapter, that was chapter 4. And then we started chapter 5. And what was chapter 5? Chapter 5 was extension to open systems. So now your basic equations that you deal with, right? I can actually show it like this. So remember when we started chapter 4, I started chapter 4 with the following. I tell you, we have this set of equation. Energy balance, some kind of polytropic equation, and equation for work done. So this first equation now will not work if you talk about open system. In open system, it will be something else. It will be different, first law, different equations. Why? Because it will be mass transfer. So what was our strategy in chapter 5? We developed this new equation and then we employ it for other devices we consider. What devices we consider so far? Nozzles, diffusers, compressor, turbines, throttling valves, mixer, heat exchangers, whatever it is. Remember this. So that our strategy was. So we have device like this. We have inlet and outlet. We have mass flow rate. So remember our basic equation. This is your equation for mass flow rate, how it looks like, right? Inlet and outlet. Again, if you come back to closed system, what does it mean? All this will be 0 and your equation will be the mass is constant. Trivial but true equation. Remember another formula that you must remember. Here are they. That mass flow rate is like this, right? Mass flow rate is coupled to volumetric flow rate. And basically mass flow rate is conserved. Again, remember, volumetric flow rate does not conserve. Mass flow rate does. So basically, if density is constant, you just conserve volumetric flow rate. In general case, don't use it, use this formula. And here are different expressions. Now, key point. We talk about moving flow, right? That's very illustrative examples. What will be energy for moving flow and non-moving flow. And what is extra term here? Extra term here is this PV term. Remember, I tell you, it's a work you need to bring here or move out your vessel with water. And if your water comes in the crane, it does there. So basically, we combine this PV, so that is a difference. And you may see that here you combine PV and U to get the same equation. So in fact, you see from here that enthalpy plays the same role for moving fluid, like internal energy for non-moving fluid, right? That's what we did. What we did next? We simply write down balance equation. So we say that, again, energy cannot be destroyed or generated. Energy change of a system, it's what? It's energy coming through heat, plus or minus energy coming through mass, and energy coming through work. That it is. And then we came to this one, and then we derived. In this equation, we realize that your work, remember what is work here? Why I show this derivation now? Because I want you to understand why this equation comes from, so you never confuse it. And basically we managed to write it like this, and these terms show you enthalpy. So it is enthalpy balance equation, and eventually it was like this. So that is your major equations that you write here in red square. So that is it in red triangle. So basically it's enthalpy balance. I recall, what is enthalpy? Enthalpy, like adjustable gross income. It's not something that exists. Energy exists in reality. It's something in your pocket. Enthalpy does not exist in reality. Enthalpy is a combination of U and PV, flow, work, and internal energy that helps you to solve the problem. But it's very helpful item. And in fact, you may see here, this equation is what? This equation is actually enthalpy balance equation. Especially, remember when you have steady flows, when you don't have this term, it will be really which only enthalpy is conserved. For all steady cases, it was enthalpy balance. Energy and enthalpy come together only for non-steady case. Remember this, right? So basically what you have to do here. So for each particular case, you write down this equation and see what's going on. For nozzles, diffuser, throttling valves, whatever it is. Correct? Read the text body. Sometimes your equation will be simplified. For instance, it may be adiabatic, so there will be no heat. It may be steady, there will be no left term. It will be no work, there will be no this term. Very often you can neglect kinetic and potential energy. There will be no these specific terms. So please pay attention. But if it's not stated, if these values are presented, you should account for them. Now, one more classical mistake that 15% of you, or maybe 50% of those who don't attend my lecture will do. Units. I do request you all the time you write something, write down your units, write down your dimensions. Because in the tables, enthalpy will be in kilojoules per kilogram, correct? When you calculate velocity, when you calculate GZ term, it will come from meters per second. It will be meter squared over second square here, which will give you joule per kilogram. So if you do numbers, just you should multiply this by 1,000 or divide this by 1,000. So I know some of you may think, okay, I will calculate, and then at the end I will put dimensions, put numbers. You will confuse. Best remedy to avoid this, always write down your dimensions. That you will not confuse. It was very good example in your quiz. In your quiz, remember, it was a problem when it was when turbine was there, and some of you forgot to multiply it by m dot when you calculate kilowatts, and your answer was 1 times less, and electronic calculator did not give you scores. If I grade it, I would give, but automatically it wasn't. You will never do this mistake if you write units. Because if you write them, your final answer will be not kilowatt, but it will be kilowatt per kilogram. And you will realize that you missed something. I do ask you to do it. Here is the classical mistakes. Remember, many of you will do it. Remember about this. 5 tons of cherries plus 6 cherries, it's not 11 cherries. And it is not 11 tons of cherries. It's 5 plus 6. Please remember this. So that's what we considered. And basically that was the idea about chapter 5. That in chapter 5, what we did? In chapter 5, we, if you remember what we did in chapter 5, we just write down our basic equation, and then we went through all examples. So for instance, when you solve problem from like this, so here is your basic equations, right? You have equation for mass balance, you have an equation for mass flow rates, and you have equation for, and you have equation for energy balance and for mass balance. Write them down, simplify, and solve. That's what you're going to do. So in particular, just in particular, what we considered. So basically, what we discussed, nozzle and diffuser. For nozzle and diffuser, typically you neglect most of the terms. So you have like this. You have this equation is equal to this, right? So in fact, you have balance between enthalpy and kinetic energy, specific enthalpy and specific kinetic energy. Again, remember, multiply by 1,000 when you are here. So that's what you may solve. For turbine, compressors, pumps is different. It's a little bit different. For them, what you have? If you have a device like this, here work input and work out is of major importance. So make sure you understand and calculate. Yes, and please remember the following. Work done by turbine will be positive. Work done on compressor will be negative if you calculate it properly. So basically, formulas are the same, but physics, mathematics is the same back to sign, but physics is opposite, right? Yeah, the question, meter squared over second squared, no. Meter squared over second squared is joule per kilogram, not kilojoule per kilogram. If you see our chart now that I'm talking, meter squared over second squared is joule per kilogram, not kilojoule per kilogram. To get kilojoule per kilogram, you should divide this value by 1,000. And we consider this, yes, because joule is Newton a meter. That's why we had chapter 1 when we discussed it. And to realize it, remember that if you had a problem, that if you had velocity of 200 meters per second in a nozzle, right? It's very big velocity. It's almost sound speed. V squared over 2 will be it will be what? It will be 40,000 over 2. It will be 20,000. But it will be 20,000 joule per kilogram, which is only 20 kilojoule per kilogram. So it will be small piece of enthalpy you have. And that's important. That's why we can use steam machine. That's why steam is very, very strong. When you have like enthalpy of 200 kilojoule per kilogram, you may realize that if you cook something and forget about it, then the roof will fly and the air velocity will be near sound speed. It's explosive. It's very strong. It's stronger than elephants, than camels, than people, than horses. That's why people use manufacturing. That's why people use engine rather than horses anymore. But it's important. That's why I tell you, it's classical mistake that you're going to do. Please make sure you realize it. Kilojoule and joules. For throttling valves, again, your device is quite simple. It's very nice for throttling. That you will simply have that H1 is equal to H2. So here it's not actually balance, it's conservation of enthalpy. It's nice to consider. And so, but what happened in throttling valve? It's actually distribution between internal energy and flow work. You submit flow work into internal energy and vice versa. And remember that for ideal gas, it will not happen. For ideal gas, HU, the all function of temperature. So ideal throttling valve does not see ideal gas because particles of zero size are not throttled. And that's why in the fridge, you have what? In the fridge, you have typically throttling valves to cooling, and it would not ever work based on ideal gas. We have a problem how temperature change, right? That's how refrigerator works. So that's why you need Freon or water in your refrigerator. Does it make sense? So that it is. Basically, then we discuss mixers and discuss heat exchangers, remember them. And remember the difference that in a mixer, you mix the flow. In heat exchanger, you keep two or more separate flows. And they may really exchange heat as we discussed. So if you have fluid A and fluid B at the end, fluid B can be colder than fluid A in the end, we discussed, right? So basically that it is. So what you should remember about your exam? People ask some questions, you can keep asking. So yes, good. It was good question. How it will be an exam? Exam, it will resemble your homework. It will resemble exam 1. It will be 4 or 5 big problems. Again, you start with multiple choice questions. Then it will be some simple calculation questions, and then it will be 2 or 3 like big problems with subtasks. Again, yes, it was a good question. I expect it will be 1 correct answer for multiple choice questions. 1 correct answer, so you don't waste time. You are recommended to do this assignment 1 by 1 because they will be to save your time. Please realize that you are not expected to waste time. So you're not you should have your brain with you, but you're not expected to think on a problem. So if you spend 5-10 minutes, you cannot clarify it, something goes wrong. Because you should be ready to write down and it should be straightforward. You don't have time for this. So if you forget tables, again, remember about tables. Remember how to use tables. Remember how should that classical mistake that you confuse tables. You confuse superheated and saturated. You confuse freon with H2O. Ideal gases. Don't confuse ideal gas with other items. If you use water and freon, most likely this is not ideal gas. And don't use ideal gas law to describe them. It's really classical and very serious mistake. Simple calculation. Yes, in your exams, there are problems very similar to what we are talking here. So that it is. Any questions, any specific question about the exam? Please ask now. Because I promised to finish at 11:50, so I will stop at 11:50 and recording, but I can keep answering your questions. The only, yeah, please.
It might have gotten lost in the chat. That's fine. But our exam is very similar to the other section's exam, I'd assume. And I know their section is getting all day to take the exam. Are we having a similar story, or are we not doing that?
What exactly? What do you take an exam? You mean?
I know some folks in the other section they have an all day exam. Like they don't have, it's not during the class period like you were planning on doing. And since the exams are similar, I was just wondering if we were getting, the similar thing.
Well, that's actually a little bit strange because no, we have different examining sessions. It's not exactly the same. And that's different because I know that people who teach it right now, Dr. Mabane and Dr. Johnson, they don't have long history of old exams. So I'm actually wondering from where they get old exams. So I do have old exams, but in fact, we discussed in the department that we don't share old exams because for two things. Because we don't want to spoil you and be prepared for those exams. Because if you give you old exams, there are two things from here that we really should drastically change it. Because if you minorly change it, it will not make sense. And if you drastically change it, you will prepare to something that you're not ready. So that's, yeah, in the past, we had experience that sometimes we really shared old exam. And I remember what was the result. The students brought old copies and wrote old, wrong answers from old exams and got F for this. And really we decided to avoid it. So you have what you need to prepare for your exams. You have your homeworks, you have your homeworks, you have your quizzes, you have solution to all of them. And if you go through them, if you know how to solve all the problems, you should be okay with your exams because they are similar.
Right. I was just wondering if we were to get like a take-home exam like the other section is getting. I just wasn't sure.
Okay. I answer like this. So I teach this. Let me answer politely like this. So we are in legal field. I teach this course for 10 years. Definitely, I used to give exam in the past. Like, if you somewhere find my old exams, I don't mind if you learn them and practice. Okay, it's not a crime. You can do it. I don't distribute it. Right. Regarding other sections, I don't know what Dr. Mabane and Dr. Johnson distribute. Right. If you want me to, I don't know the exams, and distributing the exams will not help you because I will prepare my exam. Right. So that it is. So I don't share my previous exams because I tell you why. Because I don't want you to copy that exam, and I don't want you to change everything, right? So because the problems are similar. Really, we cannot change very much. So if you solve all the exam, it will mean that you're addicted to that solutions, and you may face it at your exam, but you will not be prepared to solve something else. Does it make sense? So I tell you, well, I can ask Dr. Mabane or Dr. Johnson to share with you all the exams, what they are doing, but I don't think it will help your session practically.
That wasn't my question. Like, it wasn't about that. Don't. So please, I was just wondering. Because the other section said they have an all-day take-home exam. I was wondering if we got a similar...
okay. I'm sorry for this. Take home. No. I'm sorry. We don't give take-home exam. We have this 1 hour. And I will tell you why. Because you're expected to do exam without help, without looking at notes like usually, right? Take-home exam will mean that I cannot ask you to be in Zoom and look on you on the entire day, right? So take-home exam will mean that you have you can use any notes you want, and that's different. So I believe the exams are really harder than my exam, and they really take more time, and it's the open notes exam, isn't it?
All right, I was just curious. Thank you.
Well, I thought about this. I thought about this point, and I discussed it in the department. I discussed with Dr. Highlandly, who was responsible for the session for many years. We decided the following: if I give you, believe me, if I give you like this, exam should be really harder, because like if you have take-home exam, we are not expect you to find to Google and find solution in Google, right? So problems should be really something brainstorming, isn't it? The problem I give you in the exam, it's something that they should be straightforward to you to solve, right?
Yeah, no, that's understandable. Yep,
But well, I know some course, like I will tell you, in graduate course, in my graduate course, I give you this. In my graduate course, I give take home exam, but problems, believe me, are harder, and they really take 3-4 hours to do it. So, and so that we don't do it like this. Maybe we don't do it like at this point, okay?
Yep, gotcha, thank you.
Sorry for this.
No, it's all good.
Okay, more questions, please.
When will the question 5 solution key be up?
You can, yeah, you can submit PDF, you can submit Word, what if you want. So options like this. In fact, so it will be posted again. It will be several variants, and you don't know which variant you have. When you open your screen, it will be 5 minutes before 11. You will see Word and PDF version of your exam. You can print it out. You can use whatever you want. You can type in Word. You can type in PDF if you have a good version of PDF writer. You can print it out and write by hand and scan and send to me. Finally, final option, so it's not appreciated, but it is acceptable. You can just take piece of paper and write down answers, write down your name there, and just submit, scan and submit it. Okay. Well, yeah, I know that you can leave your play. You should be in Zoom, but when you scan and submit, you can leave it for a couple of minutes. It's okay. It's okay. I don't think you will resolve it somewhere.
My question was about the answer key to the question 5 we just did it. Not question 5, sorry, homework 5 we just did. And when
okay, yeah, I will post it. I still try to everyone to submit it. I'm going to post as soon as possible. So, but I see still not everyone submitted homework. So please, I wait 1-2 hours and then post it, because still just people ask me, give me 10 more minutes, give me half an hour more. But I will post it right, maybe by 2 o'clock. Okay. Does it make sense?
Yes, thank you.
Yeah, definitely you need it. That's why it's rigorous deadline, because you need it. You need it to go through it, and I fully understand. I am going to post it right there. Yeah. More questions, please. I will. Yeah, I stop recording at this point, but I am available, and I will be available for office hours. So